Okay, looks like it's just about time to get started. We're going to today talk about solving equations. And equations, of course, are a little bit different than expressions in that equations set two expressions equal to each other. And the nice thing with these is we can solve an equation, which means that we're going to find the value of our variable or variables. And when we're doing this, there's two essential properties, two essential kind of ideas that surround this whole idea of solving an equation. And the first thing here is we're going to talk about isolating the variable. So when we talk about isolating the variable, all we really mean is we're trying to get first just some sort of variable expression alone by itself on one side of the equation. So this is something like saying oh, this is like a x equals 3. X here is isolated. Or I could say, oh, well, -2 is equal to n. Here, my variable is isolated. It's all by itself on one side of the equation. Now, the other thing that we use here, the other main property is, or it's kind of an overarching idea here, and this is called the property or properties of equality. And broadly what this means is that anything that we do to one side of an equation, we can do the same thing to the other side. In fact, we must, because if we don't, it's not going to remain in balance. So we can add, subtract, multiply, or divide both sides of the equation. And when we do that, we're going to isolate our variable. We're going to work on making things simpler. Now, let's explore some of these basic properties here first before we move into anything a little bit more exotic. So we're going to first talk about how each of these things can be done, and then we're going to put those together, and we'll start to talk about some larger strategies. So here's what we're going to do. Let's talk about, so anytime we're adding or subtracting, we can do this to both sides of our equation. So, say we've got something like x minus 3 is equal to 8. In order to solve this, I need to get this x by itself. So what I'm going to do is I'm going to, in this case, add to both sides of the equation. Now, typically we don't always write, well, to start off with, we usually do write what we're adding to both sides. But what we don't tend to write is this, x kind of plus 0, because -3 plus 3 is equal to 0. We don't tend to write that piece there. But equal to 11? Sure. And anything, 0 plus anything is just itself, so that's x is equal to 11. We have solved this equation by simply adding. We could do, but it doesn't have to be just addition. What we're doing here is we're adding to isolate that variable. So we could do the same thing. We could do the same thing with any type of equation. Say I had something like, oh, I don't know. Say I had like -7 is equal to n plus 6. Well, here, my variable is over here on the right side of my equation, and to isolate it, I'm basically just going to ignore what's over here. I have to say, well, what do I need to do to make this just a variable? So I would need to subtract 6. This would give me, n plus 6 times, or plus a -6. That would just give me n plus 0, or just n. But what I do to one side of my equation, notice that my equal sign just stays put. What I do to one side of my equation, I do the same thing to both sides. -7 plus -6, negative plus negative is going to be a larger negative. It's going to be -13, and we're done. Very, very similarly, we could do this with either multiplication or division. And most of the time, it might seem a little contradictory, but we always start with division. But believe it or not, division is just a special type of multiplication. Actually, I should. So, if we're talking about division, this is something like saying, oh, what happens if I've got, say, 4m is equal to 20? Well, here I can't subtract away this 4. This is just a count of how many of my variables I have. 4 m's. It's like I've got 4 boxes labeled m, and I can't just say, I'm going to take 4 away. That doesn't remove the same number of boxes, but I could say, well, if I know 4 boxes contain 20, what happens if I divide it down and look at only 1 box? When I divide both sides by the same number, we can reduce these things just like a fraction. 4 goes into 4 one time. We'll be left with m on this one side. 20 divided by 4 will be 5. And there's our answer. Now, it's a little harder to see when we'd multiply, but believe it or not, this was actually a multiplication. Say I have something that looks a little bit different. Say I had like y over 3 is equal to -6. What we're doing here is we need to multiply this in order to get rid of the 3. Because technically what we're doing is we're saying, well, what happens if I take this box and I've divided it into 3 pieces? Well, what do I need in order to find out what this variable is? Well, I would need to multiply it in order to do this. So I'm going to multiply by 3, but whatever I do to one side, I do the same thing to the other. And this might help you. If you're not comfortable just multiplying by 3, why don't we multiply this by 3 over 1? And 3 over 1 and 3 are the same quantity. When I do that, I can reduce this just like a fraction. 3y over 3 would just be y. So I'll have y is equal to -6 times 3 is going to be -18. And there our answer is going to be. So anytime we have just a very simple, something simple with this, we could either add, subtract, multiply or divide to figure out what our variable is equal to. And when you state the answer, you should probably include that x equals that variable, or that number equals the variable. It doesn't matter what side of the equal sign your variable is on, it just needs to be there by itself. And the funny thing is, when you get more adept at this, you can do more things with it. Just to give you an example of that, and this is going to give you an idea, is you can, when you put these things together, you've got three very large steps, and those are usually simplify. So you simplify each side, you add or subtract, and then last but not least, you're usually going to end up dividing. And you always divide by your coefficient including the sign. So for example, if I were to do something like, say, -3 times x plus 7 is equal to 12. To simplify, I would need to distribute this. I'd have to simplify each expression. So this is going to be -3x minus 21 is equal to our 12. Next, we'd add or subtract. And again, we're trying to isolate this variable. So we want to get this, whatever our variable is attached to, we want it to be more alone with every step. So I'm going to go ahead and add 21 to both sides. I'll have -3x is equal to, looks like a 33. And last but not least, we'll divide. We divide by that coefficient including the sign. Because if you don't, you will be left with something that won't quite work. Here, negative divided by negative is positive. So -3 divided by -3 is 1. So we'll just have 1x. And 33 divided by -3, positive divided by negative is negative. And that looks like it's going to be 11. And if ever you want to check your answer, you can always check in the original question. So that would be -3. I'm going to go ahead and replace that x with a -11 plus 7 is equal to our 12. And let's see what happens. Our order of operations as we deal with what's inside our set of parentheses first. So -11 plus 7 is going to be -4. -3 times -4 is going to be a positive 12, and that looks like good math to me. 12 is in fact equal to itself. Our answer checks out. So our answer is x equals -11. Alrighty, that's all I've got for now. I will catch you in the next video.